Hello, and welcome back to Summarize Science. Today, we're talking about a key technology for deep space travel: electric propulsion. These engines are incredibly efficient, but they rely on a gas called xenon, which is extremely rare and getting more expensive every year. This cost and scarcity pose a big problem for the future of space exploration. Scientists have looked at other options, like iodine or a molecule called adamantane, but they come with their own drawbacks like toxicity or stability issues. The real challenge is that there are practically infinite possible molecules to test, making a trial-and-error approach impossible. So, how do you sort through endless possibilities? This is where artificial intelligence comes in. Researchers have created an AI tool that can predict the performance of new chemical compounds as propellants just by looking at their structure. To do this, the AI needs a way to understand what a molecule looks like digitally. They achieve this using something called a chemical fingerprint. Think of it as a unique barcode for each molecule, encoding its atoms and structure into a language the computer can process. The AI was then trained on a huge public database from the National Institute of Standards and Technology, or NIST. This database contains information on over 21,000 known compounds, giving the AI a vast library to learn from. So, what exactly is the AI trying to predict? It focuses on a few key things, like ionization energy, which is how easy it is to give the molecule an electric charge to propel it. It also predicts appearance energy, which tells us how stable the molecule is and how likely it is to break apart when ionized. Ideally, you want a propellant that's easy to ionize but doesn't shatter into useless fragments. And the results are very promising. For predicting these key energy values, the AI achieved a mean relative error of around 7 to 8%. That's significantly more accurate than just taking a wild guess. The most complex task was predicting the full mass spectrum, basically, all the different pieces a molecule breaks into when energized. Even on this difficult task, the AI's predictions scored a cosine similarity of 0.64, a strong result showing it captured the general fragmentation pattern well. Furthermore, when narrowing the search to similarly sized molecules, the correct match appeared in the top 10 predictions 78% of the time. Here on page 15, we can see a great example with adamantane, a potential propellant candidate. The blue bars are the real, measured data, and the orange bars are what the AI predicted. You can see a remarkable resemblance, especially for the taller, more significant peaks, proving the AI can identify the most important characteristics. So, let's recap the important points. The reliance on expensive xenon is holding back electric propulsion. This research demonstrates that an AI can accurately predict how new propellants will behave, using only their molecular structure as a starting point. This allows scientists to rapidly screen thousands of potential candidates without expensive and time-consuming physical experiments. This work could revolutionize how we fuel our journey to the stars. It kickstarts the development of cheaper, better-performing, and even mission-tailored propellants. Imagine designing the perfect, most efficient fuel for a specific mission to Mars or beyond, all with the help of AI. Thanks for watching Summarize Science.